So there is one number that helps us know how strong or weak an acid is. It's something called the acid dissociation constant, and its symbol is just Ka. So Ka is the acid dissociation constant. And what I can tell you is for that value here, this is what we know: the stronger the acid, the larger the Ka value. Now, I do want you to look at this table 9.3 with me. This gives us some example Ka values right here in the far right hand. And what I want you to notice is it has negative exponents. So negative exponents sometimes can trick us. But remember, the lower the negative exponent, the larger the number. So a -2, this is a larger value than a -13. This is a smaller value. And as you can see, it says increasing acidity. So at the top of these are the stronger of these ions and these, acids, and these are the weaker down here. Now, a Ka is for weak acids because remember, all strong acids are the same. They all dissociate 100%. So they wouldn't have this value. But weak acids make only partial products, but it can vary depending on the acid. So this number lets us know that, for example, phosphoric acid, based on its Ka value, its dissociation constant, is stronger than hydrocyanic acid down here. So even though they're both weak acids, one of them is actually a stronger weak acid. So Ka value, just again, is we don't memorize it, but we just need to know that the larger the Ka value, the stronger the acid would be. So I have one question that puts several ideas together, including this with the Ka value. So let's go over it. So it says, consider the two weak acids, HCN and H2CO3. Which acid has the larger Ka? Now, you wouldn't know this off the top of your head. You would either have a table or it would have given you the Ka values. Let's look back. So HCN is 4.9 times 10 to the -10. And then now I've got to go back and look at H2CO3. It's right here, and it's 4.3 times 10 to the -7. So which one is larger? Well, look at the exponents, a -10 versus a -7. Remember, the lower the negative exponent, the larger. So in this case, H2CO3 has the larger of the two Ka values. Then which acid is stronger? Okay, so H2CO3, and I'll just write the because in parentheses because we know this, it has a larger Ka value. So the larger the Ka, the stronger the acid. Then it says, which acid has the stronger conjugate base? Now, in a previous video, we talked about this relationship. So the weaker acids will have a stronger conjugate base. And the stronger acid will have a weaker conjugate base. It's opposite relationship. So let's see, they want the stronger. So we're looking for the weaker acid. So then HCN would be the weaker of the two. So weaker acid has a stronger conjugate base. And that means then this letter D is which acid has the weaker conjugate base. It has to be the stronger. So that would be H2CO3. Then letter E says, when each acid is dissolved in water, for which acid does the equilibrium lie further to the right? Okay, so anytime they talk about equilibriums and left and right, we have to know that reactants are on the left and products are on the right. Whoops, right. So if you're on the right, what this is saying is which one makes more products? Well, remember, the stronger the acid, so strong acids make 100% products. Weak acids only make partial products, but the stronger they get, the more products they make. So that's what, when you think about acids, strength has to do with how many products you're making. So which one makes more products? That's going to be the acid that is stronger. And so in this example here, H2CO3 is the stronger acid, so it will have more products.